Okay, today's lesson is 7th grade lesson 3.8. Students will investigate what it means for two quantities to vary inversely. The students will also use the formal definition as well as the formulas for inverse variations. The standard covered is 7RP2A. The page numbers are page 142 through 147 out of the hardcover book and pages 83 through 86 out of the practice journal. Today we'll be working a little bit more with inverse variation, and there's a couple of things that you need to understand. First of all, inverse variation is when you've got your quantities x and y, and they are working in opposite orders. So we kind of worked with that a little bit in our activity for 3.8, and we noticed that as we did that, as one went up, the other went down, or vice versa. So this is kind of what the graph would look like if we were to work inverse variations. The graph would have a curved line on it, versus when we did a direct variation, it had a straight line. The other thing that I want you to also identify with is the fact that we have division involved between k and x. And when we worked with direct variation, we had multiplication. The key thing on this is that k is always going to be divided by x and not vice versa. Okay, so we're going to go ahead and practice working with those formulas a little bit. So our first activity, we're going to identify whether x and y show a direct variation, an inverse variation, or neither. So we need to review really quick what our formulas look like. So our direct variation formula is when we have y by itself, it's going to be equal to k times x. Now in multiplication, they can be flip-flopped. So if it was x times k, that would still show us the same thing. Inverse variation, which is our new formula, is when we have y isolated, it is k divided by x. And the key thing is it has to be the constant or the number that we're identifying with divided by the x. It cannot be reversed because in division you cannot have them flip-flopped. So here we've got an equation that's 5 times y equals x, and we need to get it into the y equals format, or in other words, we need to isolate and get it to say y equals. So right now I have 5 times y. Well, to get y by itself, we would divide by 5. So we'll divide by 5. So I have y equals x divided by 5. So I'm seeing division. So here it kind of looks like that, but the key thing is notice where x is, it's actually on the top. So the one thing, and this is the one that's kind of tricky that you have to understand, is anytime you end up dividing by the constant or the k, you could also write that out as this. Y equals, this would be the same as 1 over 5 or 1/5 times x. So now what do we have involved there? Well, we actually have multiplication. So the only time you're going to have to really think about, is it truly an inverse variation, is if you end up dividing by the number. And just remember, then you can put a 1 over that and it becomes a direct variation. So this one would show us a direct variation because there is multiplication involved. Okay, so key thing to remember, if it's going to show inverse variation, your number has to be on the top. Okay, so if I were to rewrite this equation, maybe instead of having this, it was x times y equals 5. Okay, to get y by itself, we would divide by x, divide by x. This here would be in the proper format to show inverse variation because the x is on the bottom. The one that we just solved, we had the 5 on the bottom, so we had to rewrite it as a multiplication problem. Oops. Forgot I had my marker in my pocket there. Okay, so let's try another one. So here we've got 1/3 times y equals 1 over x. So we're working with fractions here. So normally we would divide by 1/3 to isolate. Okay, so divide by 1/3 because this is already in a fraction format and we can't just put it on the bottom. Okay, so we have to remember our rules for when we multiply, or sorry, in this case, divide fractions. We keep, so y equals 1 over x. We change to multiplication and we flip to 3 over 1. So now when I multiply straight across, because multiplying is the most basic, we get y equals 3 on the top. 1 times x is the same as 1x or x on the bottom. So I've got division involved. Does it follow this format? Do we have the constant, which is where our number should be, and then x on the bottom? We do, so this would be an indirect variation because it's showing division between the constant and the x. So today we're really just working on isolating and then identifying which of the formats it falls into. Okay, so here we have negative x equals y plus 7. So this one's set up a little different because this time the y is on this side. So we're going to have to move that 7 because we want the y by itself, not the x. Okay, so right now it's y plus 7, so we're going to subtract 7. So I've got minus 7 over here, and then still a minus x equals y. So do either of these follow that format? That one involves multiplication, this one involves division, and we're working in this one with subtraction between the x and the constant. So this would be neither, and that's because it's involving subtraction and not multiplication or division. Okay, so I want you to try this one. So go ahead and pause your video and work to isolate y, and then restart it and check yourself. Okay, this one ended up, it was kind of a tricky one because when you simplified, you ended up with 1 over 2x, which can also be written as 1/2 x, okay, which is the same as 0.5 times x. So it was showing multiplication between the two, so it ended up being a direct variation. Okay, how about this one? 1/5 times y equals x. So go ahead and pause your video and try this one. Working to get y by itself. Okay, so we ended up with x times 5. In the top portion, I just went ahead and did, to be able to cancel this out, I did the reciprocal of that, or I flipped it over, whereas in the bottom one, the way that I solved it is how I thought most of you would look at it, as dividing by 1/5 and then doing the reciprocal in the back half, like I did here when we did our keep change flip. Both of them, we ended up with y equals x times 5. So multiplication, once again, was in direct variation. So here we have, once again, direct variations showing. All right, let's try one more. This time we have y minus 1 equals 2x. So you need to work to get y by itself. So go ahead and pause your video and work through this one. This would be neither because there is addition also being involved in this equation. Okay, so that's working a little bit with the equations. So now we're going to kind of work a little bit with how indirect variation would look if it were drawn up as a graph. So here I have a graph. Oops. And then we're going to go ahead and pull some information out. So the first part I have is my table, so I'm going to go ahead and graph these. Now, the unfortunate thing about graphing them is sometimes you don't get nice perfect numbers, so we're going to have to kind of guesstimate as we graph these out. So the first one I have, x is 0.5, so remember here's my x's going across here. And then y is 6, so those are my up and down. So this one right here is the same as saying 0.5, comma 6. So I'm going to go over to 0.5 and up to 6, put my dot, approximately where it would be. Over to 1, up to 3, over to 1, up to 3, over to 3, up to 1, and then over to 6 and up to 0.5. So as I graphed this, you will notice that we ended up with a curved line. So a curved line would tell us that it is an indirect variation. Okay, so that's working when we get to graph them and see what the picture looks like. So let's try another one of those. Okay, so we've got 2, comma 10. So over to 2, up to 10. 5, comma 4, over to 5, up to 4. 8, 2.5, so over to 8, up 2 boxes, and then another half. I can already see it's curved. And I could do the 20 over 1, but mine doesn't go out to 20, but I am noticing it is a curved line. So this would once again be an indirect variation. Okay, why don't you go ahead and try this one. Identify whether or not it shows direct or indirect or neither of those variations. So go ahead and pause your video and work your way through this one, and then you can restart it to check yourself. Okay, so this time you ended up with a perfectly straight line that does cross through 0. So that would be a direct variation that we worked with back in section 2. Okay, that's basically the first part of this lesson. So good luck. Remember, for direct variations, it's going to be a straight line, and it will involve multiplication between your constant, which is your k, and your x. And for indirect variation, when you visually see the picture, it'll give you a curved line, and the equation involves division, which is k divided by x.